We're going to look at how to use exponential models dealing with questions that have percentage growth. And you can also see some of these. We'll also do some with decay as well. But the big idea is being able to write the equations and then use the equations to find missing values that they give you. So for the first exercise, they're talking about a population of fruit flies. They got a rate of 6% per hour, and they say the population starts with 28. Now, each time that we have an hour pass by, there's a 6% growth. So basically, like for this part here, where it says 1 hour, it would just be 28 times 1.06. Okay? And then that's where you get your exponent from, because every time an hour passes, you're going to multiply by 1.06 again and again. So our formula for this, they want us to use P for population in terms of time would be 28 times 1.06, and then our exponent, in this case we're using t, would be t. But when I use it and plug it into the graph in a little bit, you'll see that it's going to be equal to x, what I put in there. So for the c, we got a population when 24 hours have gone by. So I got to do 28 parentheses 1.06 with an exponent of 24. So we got 28 parentheses 1.06 and then exponent key 24. That's going to give us 113.3, and we're talking about fruit flies, so we're going to round to the nearest whole. So after 24 hours, we'd expect to see about 113. And it says, what does the calculation made in C represent about the fly population? And they want us to state the range for that domain interval. So we know it started at 28. So our range for our population is going to be between 28 and 113. And then for the last part, for E, let's move this up a little bit. They want us to use our calculator to sketch a function over the interval of 0 to 24. So we'd have 0 here, 24 at the end, and we know that we start at 28 and we get up to 113. So I'll call this right here, and again, these are all estimates. That's 28, and I'll do 113 at the top. And again, we start here at the y-intercept, and then it's going to be a gradual increase where the slope and the rate of change get increase quicker and quicker up until we get to at 24 and 113. So, and again, you want it to be as close as possible. It's not going to be exact, but they said mark the y-intercept. So there's our y-intercept, 0.28. All right, and there we have the sketch for that. So it's not going to be perfect, but we know a couple key points, and then we get the general direction of the graph. Now, we're going to look at a couple examples, multiple choice questions where you have to go ahead and write an equation or try to determine what the equation means. And in this case, for exercise 2, we have the savings in a bank account being modeled by this function. So, a couple things that we know. I mean, savings is going to be your answer, but t, I'm assuming, is going to be time. And in the case of this question, we have $250 as an initial amount. So I can cross out 2 and 4 because those both say $2.50. And then the interest, to find the interest, when you decide what is your rate, whatever our percent is, we need to make sure the number that we put in here, that's going to be the percent. R is going to equal the percent over 100. So you want to divide that by 100. So in the case of the two that we have, 4.5 and 45, if I was to take 45 and divide it by 100, with my calculator I get 0.45, which that is obviously not this because there's a 0. But if I take 4.5 and divide it by 100, I'll get 0.045, which does match what's here in the parentheses. So for that reason, this one's going to be choice 3. Now let's look at another one of these multiple choice questions. if you go to the back bottom, we're skipping over exercise 3 and we're going to look at exercises 4 and 5. So it says, for which of the following equations would model an exponential quantity that begins at a level of 16 and decreases at a constant rate of 8%? So this one is an example of decay. So with our formula, we have our, sometimes they call it principal or A value. With decay, it's 1 minus R, and then T would be our time that passed by. So in the case of this, we know it's 8%. So I'd want to take, to find R, I'd want to take 8%, 8, and divide it by 100. So that would end up being 0.08. But notice that this is subtraction, so it's 1 minus 0.08. And in the case of this 1 minus 0.08, it's going to end up being choice 1. And the other part of this, again, is the beginning at a level of 16. That would be your y-intercept. So for this one, 5, we want the principal, which is our starting amount, our y-intercept. It says we have a savings account that earns 3.5% every year, and they want us to figure out the answer for 10 years. So in this case, we know it's a savings account, so it should be increasing. So we have 350, and then we have 1 plus, and I got to find that rate by taking the percentage and dividing it by 100. So this is going to end up being, for R, 0.035. So I'm going to put a 0.035 in here, and then I'm going to stick 10 in, because it said time of 10 years. So this is going to go into your calculator, not in y equals, but in the calculation screen, and see which answer you get for that expression.